Good morning, this is your Stats Sensei, Mr. Spensei, and this is a regression, and we're going to run hypothesis tests and confidence interval on the scenario I can't drive 55. So an insurance agent reviewed the records of drivers at 12 different ages to determine if there was a relationship between a driver's age and the percentage of accidents caused by speeding. The data table and computer printout of the regression is provided below. Previously, we identified the Y row and the y-intercept row and our slope row. We said age was our x variable, so we said this is our x, and this is accidents, percent of accidents was our y. So skipping down, it says run a test, determine whether or not the slope is significant, and we need to get at alpha equal 0.01 and do the null and alternative hypotheses in symbols and then in sentences. So let's take a look at that. So slope is beta 1 equals 0. This stands for slope. All right. And by the way, if we're working with regression for this class, this will always be beta 1 equals 0, and this will always be beta 1 does not equal 0, and that's an always. Okay. And beta 1 is just like a B that leans, and we put a 1 by it. Okay. So that's how you do that. Well, what did we care about? Well, we care about age and percentage of accidents. Is there a relationship? Because determine whether the slope is significant. So we want to know, is there a relationship between age and accidents? And we always continue with the Y first. So we'll go with percent of accidents and age. So the first one, this is where things get confusing. We need to note that we start off with there is no linear relationship. All right. The key word, please, there is no. All right. Most of the time we start off with positives. This time we start off with a negative. There is no linear relationship. Even though it says equal, there is no linear relationship between the percent of accidents, which happens to be Y, and a driver's age, which happens to be X. So this is Y and this is X. The next thing, there is a linear relationship between the percent of accidents, and that's Y, and driver's age, which happens to be X. So they're just exact opposites. So there is no and there is a. Please, please, please be careful with that. The next thing it's going to ask you for is the formula. Well, the formula for this is really simple. B equals T equals B over SB. Well, first off, what is B and what is SB? Now that's a good question. All right. B and SB. Well, B is my slope, and this is SE of the slope. So if I were to go back and look at my data table, I go, oh, there's my slope, and that's my, so this is my B, and this is my SB. And you said, wait a second, that's B divided by SB. So, and it's supposed to equal T? Well, let's check that out. Negative, oops, excuse me, not point, negative 0.96065 divided by 0.0540. And sure enough, we get that equals our T statistic. Well, that just made the next part of this very easy because it's going to ask us to plug in. And so we plugged in and we get negative 0.96065 is 0.0540. The next thing is it's going to ask us what our degrees of freedom are. Well, I need you to know where they come from. Our degrees of freedom, first off, we can read it directly off the paper and they tell us it's 10. And you can write that down, but I need you to know where it comes from. It comes from our sample size because degrees of freedom equals n minus 2. So in this case, 10 minus 2, which, I mean, not 10 minus 2, 12 minus 2, because our sample size is 12. So 12 minus 2 is 10. And that's what it says here. Except this right here should have been a 12 minus 2. All right. That T statistic, well, we just calculated it on the calculator, but we can also pull it right off the sheet because when we plugged it in, 0.96065, that's our slope divided by our SB, standard error of the slope, and we got our T statistic. So here's that is. Okay, the next thing it's going to ask us to do is make a decision. Well, we have a p-value of 0. Well, even though we have a small alpha, we have an alpha of 0.01. Our p-value of 0 is definitely smaller than any alpha. So p-value 0 is less than our alpha of 0.01. Our decision is to reject the null. And this is going to be really important because this right here is going to define our next two sentences. Because it's going to say our p-value is approximately 0, which is less than our alpha of 0.01. We reject the null. Oh, look, our p-value 0, which is less than our alpha of 0.01. We reject the null. So here we go. Then it says there is sufficient evidence to suggest the true population slope results in a linear relationship between percent of accidents. And I'm having trouble this morning keeping up with my markers and pen. So percent of accidents, guess what? That's our Y, because we usually go Y before X, and a driver's age. And guess what? Driver's age happens to be X. All right, so that's our conclusion. The next thing we're going to need to do is we're going to need to do the confidence interval. And it says, number 7 says, create a 95% confidence interval for the slope. Well, we need to write our formula. And our formula is B plus or minus T star SB. Well, B happens to be our slope. This comes from the calculator. And SB is the standard error of our slope. Now, we have to be careful with this. So let's take a look at our equation, our printout. Well, our slope is negative 0.96065. That's awesome. Our SB is 0.0540. This is not T star. This is not T star. All right, T star has to come from the calculator. We're going to have to calculate it. All right, so moving on right along, let's go ahead and calculate T star. So I think that'll be the next thing it asks for. It says, hey, yeah, calculate T star. Well, to calculate T star, I'm going to need my confidence level. And they ask for a 95%, so we'll just write that down. It asks for my degrees of freedom. And remember, degrees of freedom is n minus 2, which in this case was 12 minus 2. However, I can pull it directly off of the chart where it says 10 degrees of freedom. And let's go and see if we can calculate this thing the way it's shown here. So second vars, inverse T, parenthesis, 1 minus 0.95, close parenthesis, divided by 2. Degrees of freedom was 10, or 12 minus 2 if you prefer. And being positive people, we're going to drop that negative off because we're going to turn negatives into positive. And this will be 2.2281 is our T star. Once we have our T star, we can go ahead and plug into the equation. And this is my B, this is my T star, and this is my SB. So let's take a look. Oh, T star, well, that clearly matches. All right. I look over here at my computer printout. There's my B, and my SB is 0.0540, and that's what I have. The next thing it's going to ask us to do is to actually calculate the interval. Now, the bad news is in the past, we've been able to sit there and go, hey, you know what? we'll punch buttons and we'll find a place that says interval and we'll calculate it. We can't do that here. We're going to have to plug this in. So here's what I go. I always start off with a negative first. So negative 0.96065 minus, so we're always going to start with a minus, 2.2281 parenthesis 0.0540 close parenthesis. And that gives me a negative 1.0809. And that's my lower bound. And that's what we have right here. This is my lower bound. And we always start off by doing subtraction for it first. For the upper bound, we're going to put a positive. Now, I like to make this easy. I just go arrow up, pull that down, then change that to a plus sign. And I get a negative 0.8403. And so my upper bound is negative 0.8403. So we expect the slope to be somewhere between -1 and negative 0.84. All right, so let's go ahead and write our conclusion. So what are we besides amazing? We are 95% confident that the true population slope for the percent of accidents, oh my gosh. Huh. By the way, keyword of slope, don't want to forget that. Because it's not a proportion, it's not anything but a slope. So here we have percent of accidents, which is our Y, relative to a driver's age, which is our X, lies within the interval here. So we're 95% confident the true population slope for percent of accidents relative to driver's age lies within this interval. Finally, if we did this over and over again, what would we respect? And repeated sampling, we expect this method to capture the true population slope for the percent of accidents relative to a driver's age 95% of the time. All right. Appreciate you watching. I look forward to seeing you on the next one. And just so you know, your test will look a lot like this. All righty. Talk to you later. Bye.